welcome you all to the final session of Eyes on AI, organized by IEEE on Campus, University of Peradeniya. Yesterday, we talked about the concepts and definitions of artificial intelligence, machine learning, and deep learning, as well as the mathematical concepts behind the artificial neural networks. Today, we will be guiding you to build a cats and dogs image classifier, starting from the very basics. To guide you all through this, we have our guest speaker, Ms. Veeraratna, a graduate from Faculty of Engineering, University of Peradeniya, who is currently working as an application engineer in Synopsys. Before starting today's session, I would like to remind you all that the link to the feedback form will be displayed towards the end of this session. Make sure to fill it to receive the certificate of participation. And make sure to provide the name you want in your certificate in this feedback form. Now, without any delay, I would like to invite Mr. Veeraratna to start today's session.
Yeah, we can't hear you. No, yes, we can't.
Yes, we can hear you, sir.
Yeah, thank you. Sorry for the technical difficulty that I had. So today also, yesterday the feedbacks were all good, but some people personally asked me if it will be great for them if I can conduct the second session in Sinhala. But as I said yesterday also, in order to do such thing, I have to get the approval from everyone that who is presenting today. So if any guy who cannot understand Sinhala, please talk now or use your chat.
Yes, sir.
Yeah, thank you. Right. I will conduct in English. Okay, let me share my screen. I'm unable to share my screen. Rimash, can you?
Okay, Madhura. Wait. Madhura.
Just a second, I'll check. I think you can share your screen.
Was disabled participant screen sharing. Why is that? Yeah, okay. I got it. Right. Right. So I hope you can see my slide ID here. Hello, can you see this?
Yes, sir, we can see.
Yeah, thank you. So basically, as I explained yesterday, we are going to perform a machine learning task today, and the thing that and the project that we have selected is to build an image classifier. And by this image classifier, but what we expect is to differentiate cats and dogs images. So at the end of the day, what we are going to expect is to build a machine learning model which can get the predictions when we input a cat and a dog image. Okay, this is how we are going to do this thing. Okay, first of all, I can share you my I am going to tell you the basic things that I am going to present today. So there are 3 codes that I am going to explain you today. This is the code number 1, which I have named as VGG16.py, and this is mynet.py, and this is prediction.py. So here, this is mynet.py. So when I share this codes with you using a Google Drive, you will be able to follow these codes by yourself also. So by this session, what I'm going to do is, since in order to code all these 3 programs, it will take, I don't know, it will take about 2 or 3 hours if it's going to be a if I going to conduct this session with you guys. But since that I have thought to do this session by this manner, what I'm going to do is I'm going to basically explain these codes line by line, so you will be able to get these codes when we share the codes via the Google Drive, and you can download those things and you can run it your own. I think it will be the best with the time constraint that we have. Okay, this is my code number 1. I have named it as mynet.py. So here I am going to build a neural network, a convolutional neural network, which can basically do our task. So first of all, the library. So I will tell you the libraries that I am going to use to do this task. I am going to use TensorFlow, Keras, and OpenCV. And we use OpenCV to do this. Actually, OpenCV is a library which can be used to image processing. So in here, our task also, there are some cases which we need this library. We have to handle the images, and we have to, let's say, we will have to resize the images, and we will have to convert them to, I don't know, black and white, or to grayscales. And once we have the and when we go and when we supposed to give the results, we will have to convert those images to some other kind of things. So like that, in order to handle all these things, we will have to use OpenCV library. That is why I'm going to use OpenCV. So here in this prediction code, I have import CV2, which means OpenCV, and mainly the 2 libraries that I'm going to use is TensorFlow and Keras. So here TensorFlow is a powerful machine learning tool that we can use to build machine learning programs, and Keras is used to build these neural networks kind of things. Without using Keras, by only using the TensorFlow also we can do such task, but using Keras we can do the same thing easily. So that is why I have used Keras here. So these all lines are some imports that we are going to use. So this is importing NumPy, and I'm importing Keras, and I'm going to import sequential, activation, dense flatten, all these layers. And you can see that here I'm importing activation, and here these are some 2 layers that we are going to use in our code: dense layer and flatten layer. And this is the loss function that I said yesterday, categorical cross entropy. So since we are going to import all these things, we are not going to code the loss functions by ourselves. We are going to directly use those things by this Keras library. So likewise, we can import all these things in order to do our task. And from this point onwards, you will have to follow this carefully. Okay. First of all, as I said yesterday, datasets can be divided into three categories: training data, validation data, and testing data. And most importantly, we must have at least training data set and the validation data set. So here also I have used training data set and validation data set. So the line 23, train path equals to this path. So what is the thing that is in this link? So I'm going to find the thing. So it's in the datasets archived and cats and dogs and train. So yeah, let's go. D AI datasets archived cats and dogs train. Yeah, the datasets archived cats and dogs train validation. So these are the two folders that my code is pointing, right? So let's analyze what are the things that we can find in these two folders. Here, the training folder is assigned to my train part, and the validation folder is assigned to my validate part. So in the train folder, what will we can find? Yeah, there are two folders naming cat and dog. And when we go to this cat, yeah, I can find many cats images here. And as you can see here, the images count is 5,570. And when we go to the dogs folder, it's 5,504. So roughly the number is equal to 5,500. So this is my training data set. So in order to use these libraries, you have to use these file formats. It will be actually there are many ways that we can handle data, but as the beginners you can stick to these ways because it will be more easy to you guys, easier for you guys. So in train folder, I have the two categories that I need to classify. So that is cat and dog. And in cats folder, there are cats training images. And in dogs folder, there are dogs training images. So this is my training folder, right? Then what is in the validation folder? Okay, here also the same folders can be found. But the thing is, in cats folder, there are only roughly 1,500 images. In dogs folder also, there are 1,400 means roughly we can say it's 1,500 images. So the thing is, the data that we have used in the training folder here are not the data that we have used in the validation folder. I mean, you will not be able to find any of these validation images in the training folders. That should not be done. The training images should be different than the validation images. I think you got my point. And the thing is, I have used the same amount of images in cats in both these folders. Cats also 1,500, roughly 1,500. Dogs also 1,500 for the validation. In training folder, here there are roughly 5,500. Dogs also roughly 5,500. Likewise, you have to use 1-to-1 ratio in the category folders that you are going to use here. I think you got my idea. And when we compare the image count, also you can see that in a validation datasets, we do not use that much of image when we compare with the training dataset. We have to use more training data always, right? I think now you know how to handle these data. You have to basically create the two folders, training and validation. And in training folder, you have to create another two folders which have the two categories that you need to name. And here you have to keep images in 1-to-1 ratio. And here also in validation, there also we are going to use 1-to-1 ratio. So that's that's the way that we are going to handle the directories. So is there any problem? Please ask. I hope there's no question. Right, then that is, so you can see that now in my train path, now you know where it is located, and in the validation path also now you know where it's targeting. So then what I'm going to do, I'm going to get the train batches. I have used a variable called train batches, and this is image data. Okay, give me a second.
Excuse me, is there a specific image file size or something like that resolution is recommended for this kind of stuff?
No, actually what we are going to do is yeah, I am supposed to explain that thing also. Here you can see that there's a target size which I have used as 224 by 224, which means my pixel size will be 224 times 224. So we are by this code line, we are going to resize our images to this fixed size. So it will not be an issue to use so the image resolution will not be an issue. Okay, let's see. This image has a resolution of details. It's 300 times 281. Likewise, you don't need to worry about that thing because with the library using, we are going to convert those images into the format that we need. Right?
Yeah, thank you.
Yeah. Okay. Here, I am going to get or grab the training batches from those images, so from these images folder. So how we are going to use this? So don't worry about this image data generator flow from directory. You will be able to understand those things with me. And you just mind these parameters that I'm going to use. Okay. Here, this is train path. So first of all, you need to add the path here as the first parameter, which we are supposed to grab the images. So to the train batches, which we simply can mean which we can simply mean the training images. You should get those images from the train path, this one, and then the target size. Here I have specified it to 224 times 224, and here you can use any number you need to add. It can be 50 times 50, likewise anything. So here you need to add the two classes that you are supposed to categorize at the end of the day. So here you can see that these two cat and dog names are completely similar to these folder names. So if this is cats, then there will be an error when it comes to cat. So if the folder name is cats, then this should be also this also should be renamed to cats. I think you got my idea. And here you can use the batch size. And here by batch size, I am intending that I am going to process 32 images at once. As I said yesterday, the whole neural network training can be done by batches, right? So here also, as I said, for my batches, I am going to add 32 images. I think you got my idea. So when we run this line, this 26 line, it knows that where it should find the data and what is the target image size that we're expecting, and what are the classes that it should give the predictions, and the batch size, which means the number of image count that it should process at once. So the same thing can be done to validate batches also. So here also for the validate batches, you have to say, so where should you get the validate path? This is that, and the target image size, and the classes, and the batch size. Here the batch size I have put here 32, but it can be but these two numbers can vary, right? But please don't make changes with these two numbers, because I hope it will be great. In order to truly get the meaning of validation, we need to keep these numbers same. So I hope you got my idea how to code these 4 lines, right? Then, so now we have initialized the first part. We have code the paths that we need to find data, and we have initialized the variables which we are supposed to put the images when we train the network. So when we run the 20, so as you all know, this program is going to execute from bottom. So when it runs, when we execute the 27th line, still there may not the image these train batches and validate batches will not be filled with images. This is just an assigning statement. The batch assigning case and the image gaining case will be done when we run this 40th line. So don't worry about that. I will explain that also. We are just saying here in the 26th and 27th line where to find data and what are the expecting image size that we are used in the model. I hope you have no problem with those 4 lines. Okay, now we are going to create our neural network. So these few lines are the neural network generation part. So here, what we are going to do is, by using this line, the line 29, we are going to initialize the input shape of the data that we are going to use to train our neural network. And you can see that it is 224 times 224 times 3. This 3 means there will be three color channels, which means the images that we are going to that we are supposed to input to the training to the neural network is a colored one. So there will be 3 color channels with red, green, and blue components, right? And these 224 should be coincide with these 2 parts. So if you are going to change these numbers to, let's say, 50 times 50, then here also you should change it to 50, 50, 3. So now you know how to give the input. So here also we define the image input variable that we are going to give to the neural network as input. Okay, from here onwards, this is something like a chain rule. We get this and we are going to input here, and out of this line it is going to be assigned to X, and this X is used here, and it is used here, and it is assigned to another X here, and this X is used to feed for this line, and the whole assigning part is going to be assigned to another X variable, and that is also used in here. Likewise, it's something like a chain, right? So now we know how to input an image, and then we are going to define our neural network. So this is how we are going to define the neural network. First of all, I am going to use convolutional 2D layer. So if you can remember the yesterday's session, I explained that in convolutional neural networks, the first few layers, which we call the feature extraction layers, are a combination of convolution layers, activation layers, and activation functions, and pooling layers. So you can see, I identify all these things here. This is how we define convolutional layer. And this parameter is the number of filters that we are going to use for that layer. So we are going to use, so in our example, I only use a single filter, but here I am using 32 of them. So that's how we are going to, so we are not supposed to do the filtering by using only one filter, but we are using it also by using many number of filters. So that is how we are supposed to do it. We do this filtering part simultaneously, parallelly, right? And this is the filter size. The filter size should be 3 by 3. And the activation function, after, as I said yesterday, after running the input images to the through the convolution operation, we are supposed to do add the activation function to that. So the activation function that we are going to use after that is the ReLU one, and this is just the name that I am going to give to this layer. As I said, we can name those layers like hidden layer 1, hidden layer 2, likewise. So here we are supposed to give the input layer. We are supposed to give the previous layer which comes before this line, before this convolution layer. So that is the input layer. Okay, now you have, so I think, yeah, let's just use paint and draw the neural network with this code. So there will be how I can, yeah, here. So this is my input layer. This is my image input, and this image input is supposed to go through a convolutional 2D layer, which means there will be filters. So here in this case, there will be 32 filters having 3 by 3 dimension. So, and this output is the X, and it is going, and it has been used as the input to the next layer. Okay, it goes through a max pooling layer. Okay, this is max pooling layer, and it also 2 by 2, and there also we use 2 by 2 filter size. So in max pooling layer, we do not use many filters. It will be only one filter with the filter size 2 by 2. So it will be like this filter. It will be such filter. Okay, then this output again go through another convolutional layer. It's having 64 filters. Another 2D layer, C2D, and it's 64 layers, 3 by 3 size. And again, it goes through a max pool layer. It's 2 by 2, and then 2 by 2 part. And after that, we are supposed to flatten our layer. So this input will be flattened to a data array. Right? My drawings. Okay, let me erase this thing because it will confuse you guys. So after we get the max pooling output, we are supposed to flatten it, and then this will be a flattened layer. Flatten means the output. Yeah, I can explain it. Let's say that the output of this max pooling layer is a 3 by 3 one, and it's 1, 3, 2, 4, 5, 6, 7, here and here 8, and here's 9. And after the flattened layer, it will be have this format. Here 1, 3, 2, 4, 5. Likewise, this will be the flattened layer. This one. So then this flattened layer inputs to a 64 dense 64 neurons. This flattened layer goes through a dense layer which have 64 neurons with it. So now it goes through the neural network that we know, that we are familiar with. This is the new dense layer, and the name that we call to this layer is the dense one, dense, right? And it has 64 neurons, and its activation function is relieve, and it then goes to the output layer having 2 nodes, which I have defined here. So here we have used for all these convolutional and dense layers, we have used relieve activation function. But in the last layer, we have used softmax function, right? That is because we are supposed to do the categorizing task here. As you can see that, if you can remember the way that we can draw the softmax function, it will be something like this. So the output that we are going to expect by giving through this softmax function is 1 or 0. Likewise, we can just categorize these output values to 2 numbers. So that is why we have used softmax as the output layer's activation function. So this X is the output of our entire network. Here we get the X, and here we input image input. So this is how we define the neural network in Keras. And at the end of the at the end of all these lines, we are supposed to in this way: model equals model, image input is the first layer, this one, and X is the last layer, last output, and the name of the model. So that is how we basically define the neural network. So now we know how to create the data paths and the data directories, and we know how to create the neural networks in Python. by using Keras. And then, so building all these neural networks will not give our predictions. What we need to do is we have to create, we have to define those functions, and we have to advise our algorithm to do backpropagation in order to update the weights to optimize to get the optimum values. So to do those tasks we can use this 39th line, and we before any training happen, we should compile our model. So we are going to use model.compile, and here this parameter says Adam. Okay, so the task of this Adam optimizer, actually the first parameter is the optimizer that we are going to use. So Adam is the optimizer that I have used here. So basically what Adam does is it's going to do the whole weight optimizing part. Okay, it's going to calculate the gradients, and you're going to multiply it with the learning rate, and it's basically updating our weights, which can be it's basically updating our weights in optimum way. Okay, right. Here we are going to use Adam optimizer. In most of my algorithms, which I have trained in past 2 years, I have used this Adam optimizer. So then this is the learning rate. I think you know what I mean by learning rate. And this is the loss function. So as I said yesterday, there are a few loss functions that we can use. Mean square, categorical cross entropy, likewise. And here I have used categorical cross entropy as the loss function. And this is metrics. We are going to get by this one, we are going to get the accuracies to our console. And here, so by executing this 39th line, now our model know where to find its optimizer, where to find our learning rates, what is the loss function that we are supposed to calculate the loss between the prediction and the output, the labels data. Right. In 40th line, this is where the magic happens. So here we call the fit generator function in model, and here as the first parameter I give my train batches as I give this train batches as my first parameter, and then I am supposed to give the valid batches as my second parameter. And then here is the number of epochs that I'm going to train my network. And don't worry about this verbose equals one thing. And it's just it's how we are going to support, and it's how we are going to get our console work. That's how we are. That's what we define by verbose equals one. So once we run this algorithm, you will see that these lines up to 40 up to 39 they will run very fast, but the 40th line will take much time to train, much time to execute, because that is where this whole training process is going to be happen. That is where the magic happen. The whole data propagation thing to the front to back, and then calculating the losses by using this loss function, and then the Adam optimizers process. All these things are going to be executed in line 40. Okay, then after we complete the 40th lines, we have a model which can be used to predict, to identify, to predict the correct labels of the input images that we are going to give to the model, and we are just saving that model to use. So let's see what we get when we run this code. Okay, let's see. So it's using TensorFlow as the backend. Okay, it has taken 11,019 images as the training dataset, and there are 2,975 images for the validation dataset. So this is the total numbers that we have used as our training data and validation data. And now it's training. Epoch number 1. Okay, there are a few warnings. Let's see what's going to happen. Okay, now it's training. So there are 345 batches that we can generate out of the image count. And you can see that it's training batch by batch. So here you can find the loss for an batch. So here the loss is 4.03, it's 4.05. Likewise, and here this is the accuracy. The accuracy is about 52%. So actually, what we expect from neural network training is to gain as much as accuracy that we can use to predict in the future scenarios. So at first, in the early epoch numbers, we will not be able to see that much of good accuracy and losses. But if our architecture is perfect, then these accuracy number will be increased little by little, by epoch by epochs, and the loss will be and the loss should be decreased with the epochs count here. So this is the epoch number 1. It's still running, and when this batch count goes to 345 out of 345, it's going to complete 1 epoch, and then we will be able to find the accuracy of that epoch and the loss and the overall loss of that epoch. And after running this and after training the dataset to epoch number 1, sorry about that. So when we train it, as I said, it will. So once we complete a full epoch, this number will get 345 by 345. It means that we have completed epoch number 1. And once we completed our epoch number 1, then it will try to validate to the validation data set. And we will be able to gain the validation accuracy also. And after that, we will conduct the same thing for the second epoch. So as I have used 5 epochs, this process will be continued for another 4 epochs. So let's just wait to complete this thing. And once until that, if you have any question, feel free to ask. Okay, it's taking some time to complete the epoch. Actually, here my laptop is a gaming laptop, so it means that I have GPUs in my laptop. So so to train the neural networks, we should actually have it will be good to it will be a best support. It will give the best support if we have the GPUs. So here you can see the GPU usage. It's 72.0. Yeah, I think it's getting the data from its training using the GPU. So it's going to complete the epoch number 1. So let's wait and see what will we get after we complete the epoch number 1. Those here the accuracy is still 0.55, means 55%, and the loss is 3.0. So when we train these neural networks, I think that I believe that you won't be able to get 0 losses once we converge our network, but the loss should be a minimum 1. and the accuracy should be as much as closer to 100. So here now it has completed epoch number 1 in training phase, and now it's validating to the validation dataset that we have to the validation dataset that we have input that we have given as the input. So
excuse me, sir, there's a question in the Zoom chat. Kalana is asking, what if we are using grayscale or black and white in line 29?
Yeah, then that will be 224,224,1. That's how we are supposed to use the black and white images. You have to change the input image shape.
You know how to design that architecture, which means how to design the number of filters and layers.
Yeah, actually, as I said yesterday, these values are they are actually that comes through the experiments and the experience that we are going to get through these projects. Actually, there will not be any other way to find those things, because these number of filters and the filter sizes and the activation functions can be varied from application to application also. So you need to, as I said yesterday, it will be a trial and error process. You have to run the problem, run the model to few of the architectures, and you will be able to, and you will have to select the best architecture which gets the most accuracy to a network. So here it has completed its epoch number 1, and in the first epoch, its accuracy is still 55%, and its validation accuracy is 56. So these accuracies are not good yet. My process has gained speed. Let's see what's going on. Yeah, I know now what happened. Since my battery was low, earlier for the first epoch, I don't think that it get the GPU support, and now it has gained the GPU support. So the whole process have been speed up. So that's the magic, right? I hope so. I think it's a good. It will be the best thing to do to use GPUs if you are going to train all these deep learning networks. Yeah, it's now using my GPU. Yeah, and it has completed my third epoch. So let's see what will be the validation accuracy and the training accuracy. So this is training accuracy. This is training accuracy. This is validation accuracy. So the training accuracy goes up by the epoch count. So earlier it was 55%, and now it's 59. In my third epoch, it's 61. Likewise, it should get to its best, because this means, since this here we have 61% as the accuracy, which means if we take 100 images, it will basically clarify 61 images with the correct labels. So that's why we need to get these accuracies to their best ones. So here the validation accuracy is also gaining. So your company needs to restart to complete restart now. Okay. So likewise, oh yeah, this is also a good thing to notice. So you will be able to see that these accuracy number always don't go up. It can there might be, it will go up in zigzag manner, or it will be converged to a little a small value like this. Yeah, we'll have to train this whole network to for more epochs to get the best models. So after running this my model to 5 epochs, the best accuracy that we was able to get is, let's see, it's 61%. So I have trained a neural network in front of you guys, and since we have trained it to 5 epochs, at the end of the 5 epochs, we were only able to get this accuracy number as the best. So 61% is not a good accuracy. So we have to train this neural network to more epoch count, or we will have to change our architecture. Let's say we will have to add more layers here, or we will have to change the we can change these filter values, or we can add different kind of different kind of activation functions here also. So likewise, you have to train this neural network and check those things. Because I know the those things will help you to gain the experience on neural network training. Because in future you will be it will be a huge benefit to it will be a big benefit to you guys to gain this experience by training neural networks. So as you can see, for my this neural network, it only gained about 61% validation accuracy at its best. So this is not a good number. So we can conclude our code number 1 with this with this thing. Okay. Now we are going to my second code. So this is VGG 616.5. So here, what I'm going to do is I am going to download a good neural network which has been put into the internet and it's freely available. Anyone can use that neural network. So you know about these 4 lines now. As I explained earlier, this is the training path, this is the validation path, and this is how we define the train batches, and this is validate batches. And I'm going to explain it from this 29th line. Here I have said that base model equals class.application.vg16.vg16 weights image net. So here, so let me tell you a story. This VG, there was a neural network which called AlexNet. If memory serves me right, this AlexNet was created in 2011, and this was the golden point that where the deep learning, where the ML and computer vision researchers found that using deep learning we can do magical stuff. So using that AlexNet, they were able to create and gain huge accuracies, outperforming the current, outperforming the traditional machine learning models that they used at that time. So then they were able to create VGG16 model. So that is the VGG16 model that we are going to use here. So if we go to the internet, in VGG16 architecture, let's see what is the architecture of VGG616. Yeah. So in VGG16 network, once we give our image as the input, once we give the image as our input, it will go through convolution block 1, convolution layer 1, convolution layer, another convolution layer, and then the pooling layer. Likewise, we can say that this is a convolution block. This is a convolution block which is having 2 convolution layers and a pooling layer. Likewise, there are 5 convolutional blocks in this neural network, and then there are 3. And after doing all this convolution and pooling things, it is going to flatten the outputs and use those flattened output to train the dense neural network, the neural network that we talked yesterday. So this first dense layer will have 4096 amount of neurons, and this, if memory serves me right, 4096. Yeah, it's 4096. And here also, this second dense layer will also can contain 4096 number of neurons. And here the last neural layer will contain 1000 of neurons. Since it is our output, we can easily say that the creators of this VGG16 network has created this network to clarify thousands of image categories, right? So what we are going to do here is we are going to download this network, and as I said earlier, we use this earlier part of the convolutional network as the feature extraction part, right? So, and here also you can see that there will be the filter values will be at the optimum, since they have trained this network to thousands and thousands and millions of images. So we are going to use this VGG16 model and download that into a local area in our computer, and we are going to use it to solve our problem. So let's see how we are going to do that. So here in my code, I have said, as I am going to use my base model. I am going to use VGG16 as my base model. So here I have said that I need to get the weights, the pre-trained weights from ImageNet. And here I have said include top equals false. This means when we use our VGG16 model, I am going to remove the last 3 layers, right? What I am going to do is I am going to cut this last 3 layer and last 3 layers and remove these 3 layers from the model that we are going to use, right? That is because in our network, what we definitely need is to solve our problem to categorize cats and dogs images. So basically, at our last layer, there should only be 2 neurons, not 1,000, right? That is why we are going to remove these 3 layers, but we are still going to use all these 5 blocks, which can be used to feature extraction task, right? Okay, so that is what I have said by this include top equals false, and this is the input shape. It will be 224 times 224 times 3, as the previous case, and then this is our base model. And in order to explain this, I can put x, 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 x. So yeah, now I think that these few lines are familiar to you. We have gained our base model, and this x means the output of the base model, which means output of this pooling layer, output of the flattened layer. Actually, here they have not written the flattened layer, but we are going to use the output of the flattened. Oh, sorry. Yeah, sorry, I was wrong. Here we are going to use the flattened layer, and this x means the output of the base model's output, which means the output from the last pooling layer. And after getting that last pooling layer's output, we are going to use the flattened layer to flatten them, and this x means the flattened output, and then we are going to give that to this dense layer. So I can use paint again and explain this. So by VGG16 network, this is VGG16 network, and we have removed last 3 layers. So the last layer will be the last pooling layer, and this output we have grabbed it, and then we are going to send this output through the flattened layer in our code, and then this output is supposed to go through a dense layer having 512 neurons. Okay, to explain this, I am going to comment these dropouts for now. Okay, this X then goes through another 512 dense layers. 512 number of neurons. It will be our dense layer number 2. Here also 512. Here also 512. And then it goes to a 2 neuron dense layer. So this is our output layer. So I hope you have gained what I have said here. I hope that you have understood the things that I have said here. I will repeat the process faster. So in this manner, so we have easily grabbed the BGG16 model in the by using the internet, and we are going to send our input data through this BGG16 model, and we are going to get our output from the last pooling layer, and those outputs will be sent through a flattened layer, and then these flattened outputs will be go through 3 dense layers having 512, and 2 new neurons as the output layer to the output layer. So that is how we code these things, and this is how we define our model as the previous case. Model equals model. Inputs is the base model's input, right? Here our input is the input comes here, output comes from here. So here the input is the base model input, this one's input, and the output is this one. So now we have defined our network, and then what I have said in 42 and 43 is for layer in base model dot layer dot trainable equals false, which means by these two lines I have told my neural network that you are not. I have told my optimizer that you are not supposed to train this part, this feature extraction part. You are going to train these layers only, right? Okay, but it will be I hope that it will be a good practice if we can train the front layers also, because it will be by using by training the front layers, we will be able to gain and extract the features which are those the features which can be seen in our 2 categories. So for this training scenario, I am going to put this to train. Sorry, through. So now the training process is supposed to do from back to front, not only for the new layers that we have defined, but to the front layers also, because we are going to train this neural network to customize problem. And now so actually this is the as the default values, these all these layers trainable parameter comes with true, so we can comment these lines also. So now we have defined our neural network, and here model.compile, you know about these things. The Adam is the optimizer that we are going to use, and this is the learning rate, and this is the loss function that we are going to use. This is the matrix, and we are going to use the results model.fit generator, and this is the training batches, and this is the validation batches, and here this is the epoch count, and the verbose equals 1. So once we run the network, actually it took me about 20 minutes to run this process, because there are much more layers than the previous case. So I have generated my results here. ML V16. Yeah. So this is the output that I gain by training my new algorithm. So here, once it completes its epoch number 1, you can see that the validation accuracy has gone to 80%. And when it goes to epoch number 5, it has gained to 93% value. So I hope, I think that you can remember that in my earlier case, the accuracy numbers were not that much high in the previous case. So and here also, and here you can see some other thing also. Here the accuracy, the training accuracy is 58, but the validation accuracy is 80. In the last epoch also, the training accuracy is 87, but the validation accuracy is 93%. So I did not intentionally use some easy some images which shows the cats and dogs images clearly in my validation dataset, but somehow my neural network has been trained well, and it now it's able to validate the dataset to accuracy more than its training accuracy. But this is I don't think that that overpassing the training accuracy is not a good thing to happen in the machine learning model. So I will retrain those network, or I will check whether my data set has a problem with my validation data set. But the thing that I need to say you can see these validation accuracy and the training accuracies has been gone up when we use the VGG16 model. That's because we have gained the pre-trained weights. Gained the pre-trained weights. So initially in my this network, initially there were no any pre-trained weights that we have used to train our model. We have just initialized some random variables and random numbers, and we have started our training from 0 point. But in VGG16.py code, we have used pre-trained weight file, and now we are not going to train the initial parts. We are going to already we have some good weight file, and then we are going to fine-tune the values to our application. That is the way. Actually, that means we say this process transfer learning. We are going to transfer a pre-trained weight file to a customized weight file. So that is what we have do here. That is what we have did by this code. So after running this model also, we have saved our model. So here I have saved it to saved model .hdf file. So it has about 244 megabytes, and yeah. Now you know how to train machine learning, deep learning model in two ways. The first way is to create your own convolutional neural network and train it from the beginning, and then now you know how to train a neural network by downloading a pre-trained weights and fine-tuning the weights. So this is the two ways. These are the two ways. These are some two ways that we can use in our day-to-day deep learning applications. Now we are going to go to our last code. So this is our prediction.py code. So here, so this is a small code. First, we are going to load our model. Model equals load model, and here I'm going to load my saved model, which means that I am going to use my VGG16 model. And then here I am supposed to give my input image. Image equals here I am using my OpenCV library, cv2.imread, and this is the image path. And then I'm going to resize it, since I have trained my model to predict for the input images having 224 times 224. And then I'm going to reshape my images to this array format, and then I am going to get the predictions by this line. And so let's see. So this is how we get the results. So you will be able to see two output values to each image. It will be like this. Let's say if you are going to input a cat's image, then the output of the array will be 99.99 and 0.01. So this is because we have used two new neurons as our output layer. Each neuron each new neuron is going to be going to output a single value. So this 0.99 value will come from this new neuron, and this one will come from this one. So likewise, you will get this double as the output from the output layer for each of the image. So then what I am going to do is I'm going to basically clarify that from my end. If the accuracy, if the first element is greater than the second one, then that should be a cat. If the second one is greater than the first element, then that should be a dog. So that's what I have said here. So now I have trained my neural network and I have created my prediction code. So now we can check our accuracy, check the accuracy of our model. So let's go to Google and we just search for cats images. Cats. Yeah, we can download the image and we can put it into our desktop. It's in JPEG format. It's in, I don't know this format shows, so we can download another image. What is this format? It's in GIF. So let's check if this still works for our code. So I'm going to give you this images path. So it's in my desktop. So here goes the path. Desktop, and the image name is this. So let's see the results. Yeah, it's a cat. And so as you can see, hello, you can hear me, right?
Yes, sir.
Yes, sir.
Yeah. So I have downloaded an image from internet and it predicts well to my new images also. So let's get another image. Okay, yeah, this one is a good one, right? This cat is wearing a mask. So let's see what our model is going to predict for this image. If this also predict to cat, then I think that will be great. So let's see. I am getting the image path and I'm going to paste it here. JPG format. .jpg. Yeah. Let's see. It's running. Yeah, it's a cat. So our model is doing a great job here. Even it can identify this cat also. So let's see the dogs. Next. Yeah, dog images. Yeah, there are two dogs here, cute puppies. Save image to my desktop. Okay, the image name is this one. And then results. Let's see. Yeah, it's a dog. So I think our model is doing a good job because this is the model that I'm using to predict these things is this one. The VGG. I have trained this model by using the VGG16 by transferring the weight file of the VGG16 model, and since it has 87 training accuracy and 93 validation accuracy, it's doing a good job. So this is how we can basically do a image classification task successfully. I think this one is actually a great thing. Since though this cat wears a mask, it can even the model was able to identify that it's a cat. So that's how we do So that's how basically we do such thing. So now we know how to train the models by ourselves by using this mynet.py. We can use these convolution layers and max pooling layers and flatten layers and dense layers defining to the numbers that we prefer and train that from the very beginning. And then we have checked the way that we can download the pre-trained weights from the internet and how we can fine-tune the weights and train the model. And in the prediction code, we know how to use the model that we have trained earlier. So that is how we basically so that's one way that we can do such project. So I think that's what I have to say today. So if you guys have any problem, you have time to ask. Any question about these three algorithms? Any doubts that I need to clarify to you guys?
There are some questions in the Zoom chat, sir.
Yeah, yes. So guys, my chat number 7. Okay. Do you provide us? So what if we using grayscale or black? Yeah, I have answered that. So can we change the order of filters in max pooling 2D step, same in run 2D step? So can we change the order of filters in max pooling 2D step, same as in run 2D step? I think what you are asking is, I think what you mean is that you are going to use 2 convolution layers and let's say 3 pooling layers at once. Yeah, I think that's what you mean. Yeah, we can use that thing, but actually I have not tested that case. Yeah, I don't think it will give errors, but it will. Yeah, the thing is we can change the neural networks, the architectures of the neural networks as we like to our preferences. But the thing is, all these things matter when it comes to get our accuracy. So the thing is, I am not recommending to use 3 or 2 max pooling layers at the end of a convolution layers. By using single max pooling layer will be sufficient enough to do its task. So this is because you need to. So this is why you need to understand the basics. Now you know what are we doing using a max pooling layer. So if we consider that through logically, I hope max pooling by using a single max pooling layer will do our job that we we need to that we are intended to do. So I think yeah, there will be no issues, I think, but it is some unnecessary step according to my knowledge. Yeah, how do we choose the activation function for the hidden layers? Is it always ReLU? I use ReLU function as I have actually these things also comes through the experiments and experience that you can gain in this field. What I have experienced is in most of the cases, hidden layers activation function goes with the ReLU. Earlier there was another activation function called TANH, but in AlexNet or VGG16net, the creators have changed that to ReLU, and they were able to justify that the ReLU's activation function goes very well than the TANH one, if memory serves me right. So that is why I have used ReLU one. Okay. So how can we get the GPU support to the training process? Okay. Yeah, this is a good question. Actually, in my early machine learning days, in my early days that I trained my models, I did not have a GPU with my computer. It was a i5 Dell one, but it did not have the GPU support. So, but still you can train the neural networks without having a GPU. But the thing is, it will, but the neural network will take some time to train to get its to get the best performance. You can do it by using a CPU, but the thing is, in GPU support we can use parallel processing. In parallel processing, what we do is we use that theory to calculate the values faster. So that's how we accelerate the process. So it is recommended to use the GPUs to train these networks. So first you should have a computer which has the GPU support. Then you need to install CUDA and cuDNN and a TensorFlow version which goes with your CUDA and cuDNN version. Only then you can get the GPU support for your models. So you will be able to find the instructions if you Google that question also. So what I recommend is, if you are going to give the GPU support to train the models, you should have a computer which has a GPU support inbuilt, and then you have to install CUDA and cuDNN, and you have to install the TensorFlow version which goes with that CUDA version. So I think that's an answer to that question. And then isn't it better to use sigmoid equation at the end instead of softmax, as we are doing a binary classification problem? Yeah. In sigmoid activation, it maps to 1 and it maps to -1 and +1, right? I don't remember that. Yeah, wait. Let me open my presentation to check the graph of the sigmoid and softmax. Sigmoid. No, this is the wrong one. Okay, sigmoid. Okay, this is sigmoid activation. This is softmax section. What I have used is softmax activation. It basically clarify the values to. It basically categorizes the output values to 1 and -1. Here it goes to 1 and 0. Yeah, since it's a binary case, yeah, both of these activation functions can be used, because after all, what those two activation functions do is to convert the output value to two values, either 1 or 0 to -1 or 1. I think, yeah, you can use sigmoid function also, but I have here used softmax. So those kind of things you need to get the graphs and see whether it goes with your needs. Since this is a binary classification problem, you can use softmax or sigmoid also. Yeah, I think that it will not be a problem. So where's my question window? Chat. Okay, at which point the VG16 was downloaded? Oh, is it happening inside the code? Yeah. So where is my code? This one. All right. When we run the 29th line here, if this is the first time that we are going to run this script in your computer, then at that point, when we execute the 29th line, it will download the VGG16 model by itself. So you don't need to go to a Kera's official site or any other site in the Google, and you don't need to download VGG16 model manually. It will do through this script. It will do through this line. But as I said, it will download this when we run this script for the first time in your machine. And for the second time, and when we run this script for the second time, it will basically check if the needed weight file is in your local directory. So since you have downloaded it to your local directory, now it will just use that weight file. So it will not download each time that you run the network. So sorry, my voice. Sorry for my voice. So yeah, there is another question. So what happens if we use a dog, no cat in the program? Does it give any results? Yeah, we can input another. Yeah, that's a good question. Let's check what it gives. Actually, it should give either cat or dog, right? Because here, according to the way that we have defined our network, it should only give cat or a dog. If the thing is, if we need to identify, if we need to categorize the input data to cat, dog, or any other animal, then we need to train the whole process again to 3 output predictions, which means we have to create another folder in the training and validation datasets having the name, let's say, other animals, and you need to add the, let's say, those animals who are not cats and dogs, like zebras, elephants, and I don't know, any birds images to that folder, and you need to train the network again to get the correct results. If you need to go, if you are going to if you are going to input any other images, and you need to get the correct predictions, but since we have trained this particular neural network model to identify and classify the input images only to 2 classes, there will be no error when we run the code, but it will give false predictions. So when we input an elephant image, it will sometimes it will say, okay, this is a dog, because it get confused since we have not trained to do that elephant image. But it will check, but it will still check it will try to extract the features from the elephant image, and it will check, okay, the elephant looks like it looks more similar to dog than a cat, or to cat than a dog. Then it will basically give the output a cat or a dog. So let's basically check that case. Yes, I'm going to get an elephant's image here. Okay, here we have an elephant, and I am going to download this image, desktop, so we can rerun our script to sorry, get to get the predictions for this image. So this is our elephant image. So let's run this and check the result. See this one. Yeah, we can run it again. Yeah, it says it's a dog. Yeah, as I said, we have trained our neural network only to classify to 2 classes. Here it's giving the dog's images to elephant's image also, so that can happen. So if you need to get more precise and correct images, you need to add the other animals data set to the training data and retrain the network. So what if we need to do identification between 3 image categories? Do we need to have 3 neurons at the end of it? Yeah, correct. That is a good question. As I said earlier, you need to do the whole process again. So here in AI datasets, archived, cats and dogs, train. So if you are going to add, let's say you need to identify lions also. So then you should have cats, dogs, and lions folder. Then in code, you need to change. Let's say this is the code. So here there should be another class: cat, dog, and elephant. Sorry, I said lion, right? Lion, cat, dog, and elephant. Sorry, lion. And here this should be 3. The last layer have 3 neurons. So that is the thing that you need to change for 3 cases. Okay, next question. Can you simply tell about those 32 filters? Yeah, the thing is, I cannot tell that simply. So basically what happens here is, I will try to explain this as simply as I can, as simple as I can. So basically, I explained yesterday how we derive the output when we use a single filter. Actually, here we are going to use, instead of one filter, we are going to use 32 filters of them. And here in these 32 filters, we are going to use 3 by 3 sizes for each filter. So all these numbers which lie in these 32 filters are random numbers at first, since we are going to train this from the beginning. So once we give the input image, it uses 32 filters here. As I said, included 32 here, and we are going to filter out the full image in 32 different filters and create different 32 feature maps. Likewise, and these maps are going gained through these max pooling layers, and the outputs are then again filtered out by 64 filters. Likewise, you can give any filter number here. It as earlier in yesterday I explained the whole process using a single filter, but the whole process can be done by as many as filters that you can do. This thing goes in this thing process parallel. So there will be, so it will not be an issue if you have a good GPU to perform this act. Okay. Then, so in false image recognition, Nishan, I think is it possible to set rejection criteria? Yeah. Yeah, this is what I have explained earlier. If we are going to identify another animal, then you should, yeah, as the false image recognizing, you have to enter another data set, another folder to the training and validation data paths, and train and retrain the program, retrain the algorithm to categorize the images into 3 categories: cats, dogs, and other animals. I hope that you have gained the idea. Can we use neural network to predict continuous data instead of discrete data? We are getting the continuous value. Yeah, I think you have asked that the regression area question, right? So we are using clarification. As I said earlier, we can basically divide supervised learning problems into 2 categories: regression and classification. So we have used classification here. Yeah, we can use regression also to predict neural networks. To predict regression using neural networks in the internet. So Mahela, please check. Please use Google and search by I don't remember the site. I think it's pyimagesearch.com. In that site, you will be able to just Google using pyimagesearch tag. You can search by typing how to predict housing prices using deep neural networks in PyImage search. So that will, I hope that will gain you the give the web page which explain this problem, because I remember this thing. I have given that link to many of my colleagues. So as you asked, we can perform such neural network tasks to regression also. Yeah. So is it possible to update the model while running? Is it possible to update the model while? No. It is not possible. Once we compile, then we have to compromise that our model is finalized here at this point. Then we have then we need to, and while we train the network, we cannot change any of these values. Okay. I have answered all your questions. So if you have any other question, feel free to ask. We have some time. Then is okay. There are some other questions also. Can we categorize data according to the probabilities output by the final layer? If possibility greater than threshold, then cat. Otherwise, yeah, this can be done. Actually, here, what I am doing, as I said, the output that I am getting here is a point like is a value like this one. It will be a tuple like 0.6, 0.4. So basically, we can categorize. We can threshold. We can find a threshold value like 0.4. If the value 1 is greater than 0.5, then categorize. Then give the output this one. Likewise, we can do this task. Okay, then is there a way to keep a log of the predictions and update the model later? Yeah, we can save our models accuracy and loss graph, we can use matplotlib to plot that. Actually we can get that models accuracies, and we can generate a graph which have the values of the accuracy and the losses and how they change with the epochs. So simply Google that how to use matplotlib to I don't know, get the accuracy graphs in deep learning. You will be able to find a good link there. So there, yeah. So I have used that also in my most of the code. So you can easily use that thing. So these are the questions that you have asked from me. Yeah, with the time I can give you another 2 or 3 minutes to answer the quick questions. If there is none, we can conclude the session, and you can always contact me via, I don't know, through emails or I don't know, Facebook, or using any kind of social media. I am happy to help you guys, since as you all know that I am a graduate from University of Peradeniya this year, so I know how you might struggle with your final year project. So I am always happy to help you guys in machine learning, since I'm also a machine learning enthusiast. So feel free to ask any question. So this will be the last question that I'm answering. After we create the .hdfi file, do we get our result quickly without GPU? No. Yeah. This is because so what happened in the prediction code also, once we create our .hdfi file in the training algorithm, we are dumping that file using the training algorithm, and when it comes to testing, we reload our .hdfi file, the weight file, and then we have to send our input data, and we have to send the input image through this through this weight file. And I think using GPU will accelerate the predictions also, because that's how we get the results in the so this is how we define the neural networks architecture, right? So as I explained earlier, you can calculate the output of the each neuron. So the thing is, if we use CPUs, so we are unable to use parallel processing. So we will not be able to calculate all calculate many outputs at once. So the thing is, in prediction also, by using a GPU, it will definitely accelerate the prediction, the process. Yeah, I think that will be the end of the Q&A session. So as I said, I am happy to help you guys. So feel free to contact me, and I think pretty much you can take the session from now.
Thank you, Aya. Isuri?
Yes. Since we have clarified our doubts now, I would like to invite the chairman of IET on campus, University of Peradeniya, Mr. Indura Amal, to deliver the vote of thanks.
Sorry. Thank you, Siri. Can you hear me now?
Yes, you can hear me.
Good evening, everyone. On behalf of the IET on campus University of Peradeniya, I would be glad to extend a very hearty vote of thanks to our guest speaker of the event, Engineer Mr. Sahanaka Veeraratna, for taking the time out of his busy schedule to conduct this session. I'm so grateful for the efforts and the time you took to share your knowledge and experiences with us. Also, I would like to extend my thanks to the participant for your time and unwearying attention throughout the session. I'm confident that you have learned a lot of things today. It would be very grateful if you could fill the feedback form as well. My special thank goes to our senior treasurer, Dr. Sudhir Navaratna, for always supporting us and being with us. Last but not least, I want to thank the organizing committee for all their commitment to make this event a success. Hope to see you all in our next events too. Thank you very much, and good evening, good night.
Thank you, Aya. And also the link to the feedback form is now displayed. Please submit it to receive the certificate of participation. Keep in mind that the link will be available only for an hour. And before wrapping up the session, I would like to inform you that the recorded sessions of this workshop can be accessed through our Facebook page and also through the Google Drive link provided in the reply you get after submitting the feedback form. And also, I have some exciting news for you all. There will be an e-talk organized by IET Young Professionals of Sri Lanka on infrared thermal imaging technology introduction and unlocking the true Sri Lankan industry potential on the 5th of December from 6:30 p.m. onwards. You can find the link to this event in the feedback form. This marks the end of our 2-day workshop in Artificial Intelligence, Eyes on AI. We sincerely hope that you will continue your journey on this topic through the stepping stones we have given to you today. Thank you for joining with us. Have a good night.